Okay guys, so we're on section 11.4 now, and this section is the last section we're gonna do because the rest of the sections we're just gonna review. So good job, you've made it to the last new section, and this section is about something called titrations, and it's sad because we don't actually get to do a titration. So usually this is a lab that we would do, but I'll show you a little video of one in just a second. So. First thing you need to know, though, before we even talk about titrations, is you need to know that if an acid is added to a base, the acid will neutralize the base. Okay, and usually we talk a lot more about what neutralization actually is. Basically, just know that neutralization means that the acid and base react together and they form water and a salt. So you start with two things that are potentially really dangerous and you end up with just water and some kind of salt. Could be sodium chloride, could be something else, depending on what you're reacting. And this is true in the reverse way too. So if you add a base to an acid, the base would neutralize the acid. Hopefully that makes sense that that's true. So in a titration, you are doing a reaction like this, but you're doing it to calculate some things. So a titration is adding an acid to a base, or it can be the other way around. It can be a base to an acid. My pen's running out of ink here. Or a base to an acid to find out an unknown concentration. So basically what's going on here is you put some acid in a flask or a beaker, and for some reason you don't know the concentration of that acid. Let's say you just found some acid on the street, who knows why, but you found it and you want to know how concentrated it is. So you put it in a flask and you can add some base and an indicator to it, and that can help you figure out what the concentration of that acid is. So when you do a titration, you are trying to get to something called equivalence point. And the equivalence point of a titration is the point where the moles of base or acid equal the moles of acid or base. So you want the moles of one thing to be equal to the moles of the other thing. To figure out when you're getting to equivalence point, you usually use an indicator. So if you have an acid and you don't know the concentration, you might put an indicator in that acid, and then you keep adding base until that indicator starts to change color. And when it starts to change color, you'll know that you are getting close to neutral. And when you're at neutral, that means the moles of base and the moles of acid are equal to each other. So before we move on and look at some calculation questions, I want to show you what a titration actually looks like. Okay, so I wanted to show you guys what the setup of a titration looks like, and actually what it looks like when you do one. So I'm going to hit play on this video. This is called a burette, this long skinny glass thing, and it is attached to a ring stand, which is this thin metal thing with a clamp. And the burette is where you put either the acid or the base. Often it's the base, and in this experiment it's the base. So you can see they filled up the burette, or they're going to fill up the burette with base. And then over here they've got a flask, and in the flask they're going to put acid. Okay, so I'm going to skip forward because it takes a long time to see everything that they're doing. I'm going to go to right here. So now in the flask, they've got some acid, and also in the flask there is an indicator, and the indicator that they're using is called phenolphthalein. Phenolphthalein is clear when it's in acidic solution, so right now the acid is just clear. But once there's enough base that the acid is neutralized and it starts to become basic, it's going to turn pink. So you can see it's starting to turn pink, but then the base gets neutralized by the acid. But once it's all pink and the pink doesn't go away, then the titration is over and all of the acid is neutralized. And theoretically, there should be the same amount of acid in that burette, same amount of moles of acid as there are moles of base. And then you can do calculations to figure out the concentration of the acid in that flask, which is what you would be trying to figure out in a titration like this. So anyway, that's what a titration looks like. Just thought you would want to see and understand what we're talking about. Okay, so now that you've seen what a titration actually looks like, let me give you the math equation to calculate titration problems. So this equation is going to look kind of familiar because it's really similar to another one we've used, and it is MA VA equals MB VB. Okay, you probably can guess that A stands for acid, B stands for base. Now, what does this look like, this equation? It looks like the dilution equation. Do you remember M1V1 equals M2V2? It's like that, except this time it's with acids and bases. And you solve it the same way. You probably know what these things stand for, but let's just make sure everyone's on the same page. So MA is going to be the molarity, or the concentration, of the acid. VA is going to be the volume of the acid, and remember, volume can be measured in liters or milliliters. It doesn't matter as long as your two volumes are the same unit. They have to be the same unit, or else your math gets messed up. Okay, MB is the molarity of the base, and VB is, of course, the volume of the base. So just like in dilution problems, they're going to give you three numbers and you're going to be missing one, and you have to find the one you're missing. So it's just a little super simple algebra, nothing too difficult. Okay, let's do one example, and I'm just going to move over to the other page so there's a little more room. But if you still have room on page 109, you can do it on there. Okay, so let's just write down the problem so you guys can refer to it. Problem is, if 22.5 milliliters of NaOH is necessary to neutralize 18.5 milliliters of 0.1430 molarity HNO3 solution. What is the concentration of NaOH? Okay, sorry, I know it takes a long time to write those problems out, but hopefully it's not too bad. Okay, so one of the things that confuses people in these problems is that they don't know how to figure out which thing is the acid and which thing is the base. So whichever thing starts with H, that's your acid. Because remember, acids always make H when they dissolve in water. So if there's H, that's going to be your acid. Your base is going to have OH usually, or hydroxide. So that's the base. This is not plural acids. This is just one acid. And the base has OH or hydroxide. Remember, OH is hydroxide. So this is sodium hydroxide. This happens to be nitric acid. So let's now look at all of our numbers. We've got 2 milliliters. So these are our volumes. 22.5 milliliters of NaOH. That means this must be VB, because that's describing the base, right? So that means this volume is describing the acid, which it is, 18.5 milliliters of HNO3. So that's VA. And then we have to figure out what this molarity is. So since it's written right before the acid, it's describing the acid. So that means it's the molarity of the acid. So that's MA. Okay, sometimes for people it helps them to write all of this stuff out in a list. So VB equals 22.5 milliliters. VA equals 18.5 milliliters. MA equals 0.1430 molarity. And then MB is what we don't have, and that makes sense because it's asking us for the concentration of NaOH, which would be MB. So now all we have to do is set up our equation. So remember, it's MAVA equals MB VB. So MA is 0.1430 molarity. This is for times. This little dot means times. VA is 18.5 milliliters equals MB is X times VB is 22.5 milliliters. Now I want to get X by itself, so that means I'm going to want to divide by 22.5 milliliters. Okay, and since I'm dividing, I can cross out those milliliter units, I guess. And then all I have to do is pull up my calculator and multiply those two numbers together. So we're going to do 0.1430 times 18.5. And then we're going to divide that by 22.5. And you get 0.12. We're going to round that. Oops. 0.12 molarity. NaOH. Okay. There's our answer. So a good thing to do is to just make sure that that makes sense. So our acid has this concentration. It looks like we need a little bit more base than acid to neutralize the acid, and that would make sense if the base is a little bit less concentrated. If it's a little bit less concentrated than the acid, I need a little bit more base to neutralize. Anyway, so hopefully that makes sense. That's how you do a titration problem. So let me know if you have questions. Good luck.